In this video, we're going to discuss the proof for another important theorem about convergent sequence. So let's have theorem number 3. Every convergent sequence is bounded. So ipoprove natin yan. So for our proof, let the sequence A sub n be a convergent sequence. At kung convergent sequence siya, nag-e-exist yung limit niya. So let limit of A sub n as n approaches infinity equals L. So ano yung target natin dito? Ang goal natin dito, dapat makapagpalabas tayo ng value which is absolute value ng A sub n is always less than or equal to that value, let's say m, for any n element of natural numbers. So dapat ma-prove natin yan. Okay, para masabi natin na yung sequence na A sub n ay bounded. Now, so by definition of convergent sequence, yung epsilon natin ay arbitrary. For any arbitrary epsilon, magsasatisfy yung definition ng convergent sequence. So ang gagawin natin, dapat mamili tayo ng better epsilon. So let's choose epsilon to be equal to 1. Then, may mag-e-exist pa rin na n, natural number n. Kasi ang epsilon natin, kahit ano pa yan, palaging may mag-e-exist na natural number n according to definition of convergent sequence. Such that, as for all n greater than or equal to n, to large n, the absolute value of A sub n minus L less than 1. Okay? And this implies, with the property of absolute value, negative 1 less than A sub n minus L less than 1. So, property na absolute value yan. And this is also implies, kapag nag-plus tayo ng L sa lahat ng sides na yan, magiging L minus 1 less than A sub n, makakancel na to, less than L plus 1. Okay? And this also implies 0 less than or equal to absolute value of A sub n. So, sure tayo dyan kasi nga yung property ng absolute value, this is always greater than or equal to 0. Less than absolute value of L plus 1 or 0 less than or equal to absolute value of A sub n less than absolute value of L minus 1. So, bakit ganito? Kasi hindi tayo sure kung ano yung value ng L, kung positive ba yun o negative. Okay? So, isa dito. Okay? So, ang gawin na lang natin, thus, for n greater than or equal to n, yung absolute value ng A sub n ay always less than the maximum of absolute value of L plus 1 and comma absolute value of L minus 1. Kung ano yung mas mataas sa kanila. Okay? So dito, for any n greater than or equal to n, nakakapagpalabas tayo ng value na always greater than the absolute value of A sub n. And that value is the maximum of this set. Okay? Now, paano naman sa n less than large n? Okay? So, for n less than large n, makakabuo tayo ng finite set dyan. So, we have the finite set, let's say set S equals absolute value of A sub 1, absolute value of A sub 2, up to absolute value of A sub n minus 1, since ang pinag-uusapan natin na dito yung value ng n that is less than n, large n. Okay? And since S is finite, so since S is finite, then meron siyang maximum value. Okay? So then, S has a maximum. So, yung absolute value of A sub n, for this case, n less than n, is always less than or equal sa maximum nito, nung set S. Maximum of absolute value of A sub 1, absolute value of A sub 2, up to absolute value of a sub n minus 1. So, pinakita ko lang yung mismong set for n less than large n. Okay? So, kung i-combine natin to, so iset natin yung m, combination nito, maximum nito. So, set m be maximum ng absolute value of a sub 1, absolute value of a sub 2, absolute value of a sub 3, comma, up to absolute value of a sub n minus 1, comma, absolute value of L plus 1, absolute value of L minus 1. Okay, maximum nyan. Then, for all natural number n, palagi tayo makakakita ng number which is the absolute value of a sub n is always less than or equal to that number, which is yung m. Okay? Which is yun yung gusto nating i-prove. For any natural number, the absolute value of a sub n must be always less than or equal to m. Okay? And we are done. So this proves that the convergence sequence is bounded. Therefore, the convergence sequence a sub n is bounded. So we are done. Okay, another proof ng theorem number 3. So let a sub n be a convergent sequence and let limit of a sub n as n approaches infinity equals L. Then, same lang din, choose natin epsilon equals 1. Then, may mag-e-exist by definition ng convergence sequence. Kahit anong epsilon yung pinili mo dyan, kasi arbitrary yan, palagi may mag-e-exist ng n, natural number n, that satisfy this condition. So, such that for all n greater than or equal to n, absolute value of a sub n minus L is less than 1. Okay? Then, consider absolute value of a sub n. This is equal to absolute value of a sub n minus L plus L. Okay? So, nag-minus ako ng L, nag-plus ako ng L. So, same lang yan dito sa absolute value of a sub n. And by triangle inequality, this is less than or equal. So, nahati natin sila. Magiging ano na siya, absolute value of a sub n minus L plus absolute value of L. And since the absolute value of a sub n minus L is less than 1, so this is less than 1 plus absolute value of L. Okay? Now, i-define natin yung m to be the maximum of the absolute value of a sub 1, absolute value of a sub 2, up to absolute value of a sub n, 1 plus absolute value of L. Then, the absolute value of a sub n is always less than or equal to m for any natural number n. Okay? So, we are done. This proves that the sequence a sub n is bounded. So, mas mabilis siya.